The second video lesson, looking at solutions and stoichiometry, will focus on some of the math that's involved. This requires that we understand the concept of molarity, where molarity is symbolized by a capital letter M, which stands for molar. So as an example, if we had a solution, and when I refer to a solution in the chemistry lab, this would be in a bottle with a label on it, and our label would say, in this case, 2.5 M NaCl. This tells me that the contents of the bottle, so we have contents that are a liquid in the aqueous form inside the bottle, are 2.5 molar sodium chloride. So this means that we have moles of our solute. Our solute in this example would be the sodium chloride per volume of the solvent, and most of the time our solvent will be water. Now granted, it can be other different solutions or different solvents that can dissolve things, but at our level of chemistry it's typically water. So ultimately what that does is it provides us with a derived unit of moles per liter. So our first example focuses on a 20-gram sodium hydroxide content that's going to be dissolved in a liter, and we want to figure out the molarity. So we have 20 grams of sodium hydroxide. We're going to go to the periodic table, add up the weight per 1 mole, and convert. So 20 divided by 40 will give us 0.5 moles. Then we take that 0.5 moles, because remember, molarity is moles per liter. So if this is our 0.5, we're going to then divide it by our volume, which is given at 1 liter, divide to find the molarity, and numerically our answer is 0.5. Since it's moles per liters and we're finishing the problem, we're going to convert that moles per liter into a capital letter M. And then usually what you also want to do is identify the contents so that it's labeled as specifically what chemical it is. Similar example for number 2. What is the molarity of a 3.5 liter solution that contains 90 grams of sodium chloride? So this time we have 90 grams of sodium chloride. Again, we're going to go to the periodic table and we're going to add up the weight, which is 58 grams per mole. Divide. Make sure that you keep your sig figs. We're going to take this out to 3, so 1.55 moles, and then divide by the volume. This time, remember, our volume's 3.5 liters. Okay, divide. Again, be cognizant of your significant figures. 0.443. Okay, now again, look at your units. It's moles per liter, but since we're finishing the problem, we're going to convert that to the capital letter M, and then identify that it is sodium chloride. The third example is a little bit different in that as you're looking at this one, I'd like you to focus on the fact that we're being asked to figure out moles of HCl that are present in 0.8 liters of a 0.5 molar HCl solution. My recommendation, and you'll see this a lot in upcoming examples, is that if you're given a molar solution with the capital M again, what we first want to do is take that and rewrite it as its derived units. And as we're doing that, we want to make sure that the moles is over liters. So you're writing it as a conversion factor. And then identify that it's HCl. So that's our first step. Okay, now through factor label conversion, the next thing that we know is our volume. So if we take that volume and we put it in the numerator so that it's opposite in terms of the unit, liters are now opposite. The liter unit will cancel and we'll end up just with moles. So we're going to multiply, so 0.5 times 0.8. And as we do that, We're going to get 0.4 as our answer, and the unit that's left is moles of HCl. Okay, now that's what the problem asked us to do, so technically we are finished. However, moles is not a unit that's very tangible. Typically what you'll find is these problems are going to ask you to convert it into another unit. So since you were used to doing this, let's take the moles and do a mole to gram conversion using the periodic table mass. So we'll add one more factor label from the periodic table. Hydrochloric acid has a mass of 36. So we're going to multiply, and as we do that, we should get 14.4 grams of HCl. The next type of math problem that you will run into, and you'll notice that over to the side in red, I've highlighted the fact that these types of problems that we're doing right now in this video lesson do not require a balanced chemical equation. So we're going to end this video lesson with what's called the dilution. And let's consider concentrated lemonade that you would buy at the freezer section of the supermarket, where if you think about the concentrated lemonade or orange juice or grape juice, it's going to come in a can. And you'll notice that I've highlighted this in a dark yellow to show you that it's concentrated. And typically lemonade says on the can, take the lemonade, put it into your container, and then add 4 cans of water to dilute it. And you stir it up and then you enjoy the lemonade. Well, you can do the same thing in the chemistry lab using what's called the concentration volume equation, where the values of 1 indicate that you have a concentration and a volume for your first solution or substance, and you have concentration and volume with 2's to represent your second component. And we're going to use this equation over the next problem. And again, keeping in mind that these do not require balanced chemical equations. So example number 4 is broken up into 2 parts. And as we look at these 2 parts together, they are separate. Okay, so the first part, part A, how much 12 molar HCl is needed to make 500 milliliters of 2 molar HCl. And I'm going to point out to you that our solution is still hydrochloric acid, HCl. It has not changed. So the how much part involves, in this case, finding the volume. So if we think about our equation, concentration times volume equals concentration times volume, we have 12 molar HCl, but we don't know the volume. We're going to set that equal to our second set of conditions, which is given 2 molar HCl, our concentration, times 500 milliliters. Okay, so in order to isolate the volume term by itself, we're going to multiply the 2 times 500, which is going to be 1,000, and then divide both sides by 12. And as we do that, again, keeping in mind sig figs, we're going to get 83.3 milliliters total for our answer. Our second and final example for this video lesson, part B, says that we have 0.35 liters of 12 molar HCl, so there's our first set of conditions, and it's diluted to 0.65 liters. What's the resulting molarity? So this time we know the concentration and the volume of the first set of conditions. What we don't know is the resulting molarity. In other words, we don't know the concentration, but we know that the volume is 0.65 liters. So then again, multiply and then divide both sides by 0.65. And when you do that, you should get 6.5 molar as your resulting molarity. So this concludes your second video lesson for solutions in stoichiometry.